So now alkenes, very similar to alkanes, also has similar physical properties. And so we're going to be studying the same thing. So now alkenes are also simple molecular structures, okay, and they have weak forces of attraction, okay, forces of attraction. And how does this go in detail is not something that you should be looking to get in right now, because that is more part of your A-level syllabus. So you just need to know right now that these are simple molecular structures and they have weak forces of attraction. And because they have weak forces of attraction, they have low melting and boiling points. Low melting and boiling points. Okay. Right. So let's say if I were to talk about ethene, so ethene, now that has a boiling point of minus 104. Okay. And if I were to talk about propene, that has a boiling point of minus 48. And similarly, if I were to talk about butene, that has a boiling point of minus 6. And the same thing that you guys will notice here is that down the series, what's happening? Down the series, the low melting and boiling points are actually increasing. And boiling points, I haven't mentioned boiling points here yet. Oh, sorry, I have mentioned boiling points. I haven't mentioned melting points yet. But the low melting and boiling points, as we go down the series, as we go from ethene to propene, basically as we increase the number of carbon molecules, number of carbon atoms, sorry, as we increase the number of carbon atoms, the melting and boiling points are going to increase. So you see from minus 104, you go to minus 48, and then you go to minus 6. So this is an increase in temperature, okay? You should be able to register that. You should not think that this is a decrease in temperature. This is an increase in temperature. All right. So this is how this works. And if I were to talk about the forces of attraction, so as we go down the series, the forces of attractions increase. Okay. Forces of attraction increase, and that is also the reason why the melting and boiling points are increasing. Remember, when the forces of attraction are low, at ethene, when the forces of attraction are low, so the melting and boiling points are also low. But as we go down the series, the forces of attraction are increasing, and that's because, and for that reason, melting and boiling points are also increasing. I'll just write it here. Increase. Okay. Down the series. So this is it. And if we just quickly compare these two, so let's look at this table. I feel like this is pretty blurred, but I'll just mention it here. So this is minus 169. We're talking about melting point. So this is minus 169 degrees centigrade. This is minus 165. I think this is also 165. This is also 165. This is 140. This is minus 119. Minus 104, minus 94, minus 87. So the the melting points are increasing as we go down the series, and the boiling points are also increasing as we go down the series. Okay, and you can also look at the condition at the physical condition at the room temperature. So ethene, propene, and butene, these three are gases. Pentene, hexene, heptene, these three are liquid. All of the others are liquid. Okay, you might just want to remember these three, that these three are gases at room temperature. Okay, and you don't need to remember the density or the molar mass or anything. Okay, and if we were to compare the same with alkanes here, so you see, the main difference here is that here the melting point is minus 182, minus 183, minus 187, minus 138. So the general trend is same, that they are increasing down the series, but alkenes generally have higher melting point. Like if you notice, they have higher melting and boiling points compared to alkenes, right? So the boiling point for alkenes is minus 169, and it has minus 182. The boiling point is minus 103, and it has minus 161. If we talk about this, now this has the boiling point of minus 185. Okay, so this is 165, sorry. 165, so this is minus 183. If we talk about this, the boiling point is minus 46, and the boiling point here is minus 88.6. So that's just just different perspective or different kind of thing that you guys might want to know. Okay, so this is the thing about melting and boiling points. Now let's talk about viscosity. And I've explained that in detail. Viscosity is basically the liquid's ability to flow. If we compare it with ketchup, like if we talk about water flows more easily because it is a thin liquid, right? It is a thin liquid. It flows easily. If you double down the container of a bottle, the water is going to flow easily. But if you double down the container of a ketchup or you can say honey or something like condensed milk, it's going to flow out very slow, right? Because of its thickness. So that flowness of the liquid is something that we call viscosity. I don't even know if flowness is a word, but I just used it. Okay. So that is what viscosity is. And if you talk about viscosity, what happens basically is that when we go down the series, I'll just take it from here. When we go down the series, right, like this, so the viscosity increases. Okay. I don't know if that's the spelling. Yeah, that is the spelling. Viscosity increases. Okay, because what's happening as we go down the series, as we go from ethene, propene, butene, pentene, hexene to all of the other molecules, as we go down the series, the thickness of the liquid is increasing, and that's why the viscosity is increasing, right? But the molecular sizes are increasing, right? So the viscosity is also increasing, and this is also due to the stronger force of attraction between alkene molecules, because that's what I also told you just above that. As we go down the series, the forces of attractions are going to increase. Okay, that's one thing. Now, if we talk about solubility, that is one more thing that we need to know, and this is pretty much same as alkenes. So the solubility, alkenes are insoluble in water. Okay, insoluble in water, but they are soluble in most organic solvents. So they are soluble in most organic solvent, and one of the solvents are the same one, tetrachloromethane. So that's CCl4. Or there's one more which I don't seem to remember right now. That molecule is hexane. Okay, I just remember it. That molecule is hexane, which is C6H14. Okay, and one more thing that you guys might want to know is that when we talk about liquid alkenes, we're talking about alkenes, not alkenes. When you talk about liquid alkenes, we use them as solvents. Okay, we can use liquid alkenes as solvents, but we cannot use liquid alkenes as solvents. And the reason behind that is alkenes are more reactive. So when you use them in reaction as solvents, they're gonna react with other with other reactants. So because alkenes are generally unreactive, we can use them as solvents. But because alkenes are reactive as solvents, or alkenes are generally reactive, we don't use them as solvents. Okay. All right. I hope that's clear. Perfect.